Hey guys, my name is Jacob Sanders. Go check out my blog on programming at pieharbor.com. This video is going to be a reading of RFC 7519 on JSON Web Tokens. I'm going to jump right into it. Abstract. JSON Web Token, or Jot, is a compact URL-safe means of representing claims to be transferred between two parties. The claims in a Jot are encoded as a JSON object that is used as the payload of a JSON Web Signature, JWS structure, or as the plaintext of a JSON Web Encryption structure, a JWE, enabling the claims to be digitally signed or integrity protected with a message authentication code and or encrypted. I'm going to skip over the status of this memo. I'm going to skip over the copyright. I'm also going to skip over the table of contents. I'm going to start at the introduction. JSON Web Token is a compact claims representation format intended for space-constrained environments such as HTTP authorization headers and URI query parameters. Jots encode claims to be transmitted as JSON, as a JSON object that is used as the payload of a JSON Web Signature structure, or as the plaintext of a JSON Web Encryption structure, enabling the claims to be digitally signed or integrity protected with a message authentication code and or encrypted. Jots are always represented using the JWS compact serialization or the JWE compact serialization. The suggested pronunciation of JWT is the same as the English word Jot, and that's what I'm going to be doing. I'm going to try and do that in this reading. Section 1.1, Notational Conventions. The keywords must not, required, shall not, should not, recommended, may, and optional in this document are to be interpreted as described in keywords for use in RFCs to indicate requirement levels, specified in RFC 2119. The interpretation should only be applied when the terms appear in all capital letters. Section 2, Terminology. The terms JSON Web Signature, base 64 URL encoding, header parameter, JOSE header, JWS compact serialization, JWS payload, JWS signature, and unsecured JWS are defined by the JWS specification. The terms JSON Web Encryption, content encryption key, JWE compact serialization, JWE encrypted key, and JWE initialization vector are defined by the JWE specification. The terms ciphertext, digital signature, message authentication code, and plaintext are defined by the Internet Security Glossary version 2, or RFC 4949. These terms are defined by this specification: JSON Web Token, or Jot, a string representing a set of claims as a JSON object that is encoded in a JWS or JWE, enabling the claims to be digitally signed or MAC'd and or encrypted. Jot Claim Set, a JSON object that contains the claims conveyed by the JWT. Claim, a piece of information asserted about a subject. A claim is represented as a name-value pair consisting of a claim name and a claim value. Claim name, the name portion of a claim representation. A claim name is always a string. Claim value, the value portion of a claim representation. A claim value can be any JSON value. Nested Jot, a Jot in which nested signing and or encryption are employed. In nested Jots, a JWT is used as the payload or plaintext value of an enclosing JWS or JWE structure respectively. Unsecured Jot, a Jot whose claims are not integrity protected or encrypted. Collision-resistant name, a name in a namespace that enables names to be allocated in a manner such that they are highly unlikely to collide with other names. Examples of collision-resistant namespaces include domain names, object identifiers, or OIDs, as defined in the ITU-T X.660 and X.670 recommendation series, and universally unique identifiers, or UUIDs, defined in RFC 4122. When using an administratively delegated namespace, the definer of a name needs to take reasonable precautions to ensure they are in control of the portion of the namespace they use to define the name. String or URI, a JSON string value with the additional requirement that while arbitrary string values may be used, any value containing a semicolon character must be a URI, as defined in RFC 3986. String or URI values are compared as case-sensitive strings with no transformations or canonicalizations applied. Numeric date, a JSON numeric value representing the number of seconds from 1970 0101 0000 UTC until the specified UTC date time, ignoring leap seconds. This is equivalent to the IEEE standard 1003.1 2013 edition POSIX.1 definition. Seconds since the epoch, in which each day is accounted for by exactly 86,400 seconds other than non-integer values can be represented. See RFC 3339 for details regarding date times in general and UTC in particular. Section 3, JSON Web Token Overview. Jots represent a set of claims as a JSON object that is encoded in a JWS and/or JWE structure. This JSON object is the JWT claim set. As per Section 4 of RFC 7159, the JSON object consists of 0 or more name-value pairs or members, where the names are strings and the values are arbitrary JSON values. These members are the claims represented by the Jot. This JSON object may contain whitespace and/or line breaks before or after any JSON values or structural characters, in accordance with Section 2 of RFC 7159. The member names within the Jot claim set are referred to as claim names. The corresponding values are referred to as claim values. The contents of the JOSE header describe the cryptographic operations applied to the Jot claim set. If the JOSE header is for a JWS, the Jot is represented as a JWS and the claims are digitally signed or MAC'd, with the Jot claim set being the JWS payload. If the JOSE header is for the JWE, the Jot is represented as a JWE and the claims are encrypted, with the Jot claim set being the plaintext encrypted by the JWE. A Jot may be enclosed in another JWE or JWS structure to create a nested Jot, enabling nested signing and encryption to be performed. A Jot is represented as a sequence of URL-safe parts separated by period characters. Each part contains a base 64 URL encoded value. The number of parts in the Jot is dependent upon the representation of the resulting JWS using the JWS compact serialization or JWE using the JWE compact serialization. Section 3.1, Example Jot. The following example JOSE header declares that the encoded object is a Jot, and the Jot is a JWS that is MAC'd using the HMAC SHA-256 algorithm. And here we see some JSON with the key TYP and the key ALG with the values Jot and HS256. To remove potential ambiguities in the representation of the JSON object above, the octet sequence for the actual UTF-8 representation used in this example for the JOSE header above is also included below. Note that ambiguities can arise due to differing platform representations of line breaks, carriage return line feed versus line feed, differing space at the beginning and ends of lines, whether the last line has a terminating line break or not, and other causes. In the representation used in this example, the first line has no leading or trailing spaces. A carriage return line feed line break at 1310 occurs between the first and second lines. The second line has one leading space. Okay, I see. And no trailing spaces, and the last line does not have a terminating line break. The octets representing the UTF-8 representation of the JOSE header in this example using JSON array notation are, and then it has all of those octets. The base 64 URL encoding the octets of the UTF-8 representation of the JOSE header yields this encoded JOSE header value. And then it has the base 64 form. The following is an example of a Jot claim set. And then it has the ISS Joe, EXP with a timestamp. As it stated before, that's basically just seconds after that 1970 January 1st, time, and then the following octet sequence, which is the UTF-8 representation used in this example for the Jot Claim Set above, is the JWS payload. And okay, and then there's the base64 URL encoding, the JWS payload. Right, so base64 URL encoding the JWS payload yields this encoded JWS payload. And that's the base64 form. And then computing the MAC of the encoded JOSE header and encoded JWS payload with the HMAC SHA-256 algorithm and base64 URL encoding, the HMAC value in the manner specified in JWS yields this encoded JWS signature. Concatenating these encoded parts in this order with period characters between the parts yields this complete JWT, with line breaks for display purposes only. This computation is illustrated in more detail in Appendix A.1 of JWS. See Appendix A.1 for an example of an encrypted Jot. Section 4. JWT Claims. The JWT claims set represents a JSON object whose members are the claims conveyed by the JWT. The claim names within a JWT claim set must be unique. JWT parsers must either reject JWTs with duplicate claim names or use a JSON parser that returns only the lexically last duplicate member name, as specified in section 15.12, the JSON object. The set of claims that I'm going to call JWT Jot. They suggest doing that earlier in this, and I like that because it's a single syllable. So from now on, that's going to be how I refer to it. Where was I? Jot parsers must either reject Jots with duplicate claim names or use a JSON parser that returns only the lexically last duplicate member name, as specified in section 15.12. The set of claims that a Jot must contain to be considered valid is context dependent and is outside the scope of this specification. Specific applications of Jots will require implementations to understand and process some claims in particular ways. However, in the absence of such requirements, all claims that are not understood must be implementations must be ignored. There are three classes of JWT claim names: registered claim names, public claim names, and private claim names. Section 4.1, Registered Claim Names. The following claim names are registered in the IANA JSON Web Token Claims Registry, established by Section 10.1. None of the claims defined below are intended to be mandatory to use or implement in all cases, but rather they provide a starting point for a set of useful interoperable claims. Applications using Jots should define which specific claims they use and when they are required or optional. All the names are short because a core goal of Jots is for the representation to be compact. Okay, that makes sense. Section 4.1.1, ISS, Issuer Claim. The ISS issuer claim identifies the principal that issued the Jot. The processing of this claim is generally application specific. The ISS value is a case-sensitive string containing a string or URI value. Use of this claim is optional. Section 4.1.2, the subject claim, spelled S-U-B, sub. The sub claim identifies the principal that is the subject of the Jot. The claims in a Jot are normally statements about the subject. The subject value must either be scoped to be locally unique in the context of the issuer or be globally unique. The processing of this claim is generally application specific. The sub value is a case-sensitive string containing a string or URI value. Use of this claim is optional. Section 4.1.3, AUD or audience claim. The AUD audience claim identifies the recipients that the JWT is intended for. Each principal intended to process the JWT must identify itself with a value in the audience claim. If the principal processing the claim does not identify itself with a value in the odd claim when this claim is present, then the Jot must be rejected. In the general case, the odd value is the AUD value is an array of case-sensitive strings, each containing a string or URI value. In the special case, when the JWT has one audience, the AUD value may be a single case-insensitive string containing a string or URI value. The interpretation of the audience values is generally application-specific. Use of this claim is optional. Section 4.1.4, the expiration time claim. The EXP, or expiration time claim, identifies the expiration time on or after which the Jot must not be accepted for processing. The processing of the EXP claim requires that the current date time must be before the expiration date time listed in the EXP claim. Implementers may provide for some small leeway, usually no more than a few minutes, to account for clock skew. Its value must be a number containing a numeric date value. Use of this claim is optional. Section 4.1.5, the NBF, or not before claim. The NBF, or not before claim, identifies the time before which the Jot must not be accepted for processing. The processing of the NBF claim requires that the current date time must be after or equal to the not before date time listed in the NBF claim. Implementers may provide for some small leeway, usually no more than a few minutes, to account for clock skew. Its value must be a number containing a numeric date value. Use of this claim is optional. Section 4.1.6, the IAT, or issued at claim. The IAT, or issued at claim, identifies the time at which the Jot was issued. This claim can be used to determine the age of the Jot. Its value must be the number containing a numeric date value. Use of this claim is optional. Section 4.1.7, the JTI, or Jot ID claim. The JTI, Jot ID, claim provides a unique identifier for the Jot. The identifier value must be assigned in a manner that ensures that there is a negligible probability that the same value will be accidentally assigned to a different data object. If the application uses multiple issuers, collisions must be prevented among values produced by different issuers as well. The JTI claim may be used to prevent the Jot from being replayed. The JTI value is a case-sensitive string. Use of this claim is optional. Section 4.2, public claim names. Claim names can be defined at will by using Jots. However, in order to prevent collisions, any new claim name should either be registered in the IANA JSON Web Token Claims registry established by Section 10.1 or be a public name, a value that contains a collision-resistant name. In each case, the definer of the name or value needs to take reasonable precautions to make sure they are in control of the part of the namespace they use to define the claim name. Section 4.3, private claim names. A producer and consumer of a Jot may agree to use claim names that are private names, names that are not registered claim names, or public claim names. Unlike public claim names, private claim names are subject to collision and should be used with caution. Section 5, the JOSC header. For a Jot object, the members of the JSON object, represented by the JOSC header, describe the cryptographic operations applied to the Jot and optionally additional properties of the Jot. Depending upon whether the Jot is a JWS or a JWE, the corresponding rules for the JOSC header values apply. This specification further specifies the use of the following header parameters in both the cases where the where the Jot is a JWS and where it is a JWE. Section 5.1, the TYP, or type header parameter. The TYP, or type header parameter, defined by JWS and JWE, is used by Jot applications to declare the media type of this complete Jot. This is intended for use by the Jot application when values that are not Jots could also be represented in an application data structure that can contain a Jot object. The application can use this value to disambiguate among the different kinds of objects that might be present. It will typically not be used by applications when it is already known that the object is a Jot. This parameter is ignored by Jot implementations. Any processing of this parameter is performed by the Jot application. If present, it is recommended that its value be Jot, or that its value be JWT to indicate that this object is a Jot. While media type names are not case sensitive, it is recommended that Jot always be spelled using uppercase characters for compatibility with legacy implementations. Use of this header parameter is optional. Section 5.2, the CTY or content type header parameter. The CTY or content type header parameter defined by JWS and JWE is used by this specification to convey structural information about the Jot. In the normal case, in which nested signing or encryption operations are not employed, the use of this header parameter is not recommended. In the case that nested signing or encryption is employed, this header parameter must be present. In this case, the value must be JWT to indicate that a nested Jot is carried in this Jot. While media type names are not case sensitive, it is recommended that the Jot always be spelled using uppercase characters for compatibility with legacy implementations. For example, a nested Jot. Section 5.3, replicating claims as header parameters. In some applications using encrypted Jots, it is useful to have an unencrypted representation of some claims. This might be used, for instance, in application processing rules to determine whether and how to process the Jot before it is decrypted. The specification allows claims present in the Jot Claim Set to be replicated as header parameters in a Jot that is a JWE as needed by the application. If such replicated claims are present, the application receiving them should verify that their values are identical, unless the application defines other specific processing rules for these claims. It is the responsibility of the application to ensure that only claims that are safe to be transmitted in an unencrypted manner are replicated as header parameter values in the JWT. Section 10.4.1 of this specification registers the ISS or issuer, the SUB or subject, and the AUD or audience header parameter names for the purpose of providing unencrypted replicas of these claims in encrypted JWTs for applications that need them. Other specifications may similarly register other names that are registered claim names as header parameter names as needed. Section 6, Unsecured Jots. To support use cases in which the Jot content is secured by a means other than a signature and/or encryption contained within the Jot, such as a signature on a data structure containing the Jot, Jots may also be created without a signature or encryption. An unsecured Jot is a JWS using the ALG header parameter value none and with the empty string for its JWS signature value, as defined in the JWA specification. It is an unsecured JWS with the Jot Claim Set as its JWS payload. Section 6.1, Example Unsecured Jot. The following example JOSE header declares that the encoded object is an unsecured Jot, and it shows the ALG key having the value none, literally the string none. Base 64 URL encoding the octets of the UTF-8 representation of the JOSE header yields this encoded JOSE header value. Then it shows the base 64 representation of that. The following is an example of a Jot Claim Set. Here we have the issuer claim, the expiry claim, and the I'm not really sure what the last one is, but it's basically a URI or a URL. Okay, so the following is an example of a JWT claim set. This is the base 64 URL encoding. Base 64 URL encoding the octets of the UTF-8 representation of the JWT claim set yields this encoded JWS payload with line breaks for display purposes only. Okay, there you go again. The encoded JWS signature is the empty string. Concatenating these encoded parts in this order with period characters between the parts yields the complete JWT, yields this complete Jot with line breaks for display purposes only. Okay, Section 7, Creating and Validating Jots. Section 7.1, Creating a Jot. To create a Jot, the following steps are performed. The order of the steps is not significant in cases where there are no dependencies between the inputs and outputs of the steps. Section, I guess this is just a step or something? Yeah. So step 1, create a Jot claim set containing the desired claims. Note that the white space is explicitly allowed in the representation, and no canonicalization needs to be performed. Need be performed before encoding. Step 2. Let the message be the octets of the UTF-8 representation of the Jot Claim Set. Step 3. Create a JOSC header containing the desired set of header parameters. The JWT must conform to either the JWS or JWE specification. Note that whitespace is explicitly allowed in the representation and no canonicalization need be performed before encoding. Step 4. Depending upon whether the Jot is a JWS or a JWE, there are two cases. 1. If the Jot is a JWS, create a JWS using the message as the JWS payload. All steps specified in JWS for creating a JWS must be followed. Else, if the Jot is a JWE, create a JWE using the message as the plaintext for the JWE. All steps specified in JWE for creating a JWE must be followed. And, step 5 is if a nested signing or encryption operation will be performed, let the message be the JWS or JWE and return to step 3 using a CTY, which is content type value of Jot, in the new JOSC header created in that step. Step 6. Otherwise, let the resulting Jot be the JWS or JWE. Okay. Section 7.2, validating a JWT, validating a Jot. When validating a Jot, the following steps are performed. The order of the steps is not significant in cases where there are no dependencies between the inputs and outputs of the steps. If any of the listed steps fail, then the Jot must be rejected, that is, treated by the application as an invalid input. Step 1, verify that the Jot contains at least one period character. Step 2, let the encoded JOSC header be the portion of the Jot before the first period character. Step 3. Base 64 URL decode the encoded JOSC header, following the restriction that no line breaks, whitespace, or additional characters have been used. Step 4. Verify that the resulting octet sequence is a UTF-8 encoded representation of a completely valid JSON object conforming to the RFC 7159. Let the JOSC header be this JSON object. Step 5. Verify that the resulting JOSC header includes only parameters and values whose syntax and semantics are both understood and supported, or that are being ignored when not understood. Step 6. Determine whether the Jot is a JWS or a JWE using any of the methods described in Section 9 of JWE. Step 7. Depending upon whether the Jot is a JWS or a JWE, there are two cases. If the Jot is a JWS, follow the steps specified in JWS for validating a JWS. Let the message be the result of base 64 URL decoding the JWS payload. Else, if the Jot is a JWE, follow the steps specified in JWE for validating a JWE. Let the message be the resulting plaintext. Step 8. If the JOSC header contains a CTY or content type value of Jot, then the message is a Jot that was the subject of nested signing or encryption operations. In this case, return to step 1 using the message as the Jot. Step 9. Otherwise, base 64 URL decode the message following the restriction that no line breaks, whitespace, or other additional characters have been used. Step 10. Verify that the resulting octet sequence is a UTF-8 encoded representation of a completely valid JSON object conforming to RFC 7159. Let the Jot Claim Set be this JSON object. Finally, note that it is an application decision which algorithms may be used in a given context. Even if a Jot can be successfully validated, unless the algorithms used in the Jot are acceptable to the application, it should reject the Jot. Okay, Section 7.3, String Comparison Rules. Processing a Jot inevitably requires comparing known strings to members and values in JSON objects. For example, in checking what the algorithm is, the Unicode string encoding ALG will be checked against the member names in the JOSC header to see if there is a matching header parameter name. The JSON rules for doing member name comparison are described in Section 8.3 of RFC 7159. Since the only string comparison operations that are performed are equality and inequality, the same rules can be used for comparing both member names and member values against known strings. These comparison rules must be used for all JSON strings, JSON string comparisons, except in cases where the definition of the member explicitly calls out that a different comparison rule is to be used for that member value. In this specification, only the type N or the TYP and the CTY or type and content type member values do not use these comparison values or comparison rules. CTY is content type, yeah. Okay. Some applications may include case-insensitive information in a case-sensitive value, such as including a DNS name as part of the ISS or issuer claim value. In those cases, the application may need to define a convention for the canonical case to use for representing the case-insensitive portions, such as lowercasing them if more than one party might need to produce the same values so that they can be compared. However, if all other parties consume whatever value the producing party emitted verbatim without attempting to compare it to an independently produced value, then the case used by the producer will not matter. Section 8, Implementation Requirements. This section defines which algorithms and features of this specification are mandatory to implement. Applications using this specification can impose additional requirements upon implementations that they use. For instance, one application might require support for encrypted jots and nested jots, while another might require support for signing jots with the elliptic curve digital signature algorithm, also known as ECDSA, using the P256 curve and the SHA-256 hash algorithm, ES256. Of the signature and MAC algorithms specified in the JSON web algorithms, only HMAC SHA-256 and none must be implemented by the conforming JWT implementations. It is recommended that implementations also support RSA SSA PKCS1 v15 with the SHA-256 hash algorithm RS256 and the ECDSA using the P256 curve and the SHA-256 hash algorithm. Support for other algorithms and key sizes is optional. Support for encrypted jots is optional. If an implementation provides encryption capabilities of the encryption algorithm specified in JWA, only the RSAES PKCS1 v15 with 2048-bit keys, the AES key wrap with 128 and 256-bit keys, and composite authenticated encryption algorithm using AES CBC and HMAC SHA-2 must be implemented by conforming implementations. It is recommended that implementations also support using elliptic curve Diffie-Hellman ephemeral static to agree upon a key used to wrap the content encryption key, and AES in Galois counter mode, GCM, with 128 and 256-bit keys. Support for other algorithms and key sizes is optional. Support for nested jots is optional. Section 9. URI for declaring the content in a jot. This specification registers the URN for use by applications that declare content types using URIs, rather than, for instance, media types to indicate that the content referred to is a jot. Section 10. IANA considerations. Section 10.1 JSON Web Token Claims Registry. This section establishes the IANA JSON Web Token Claims Registry for Jot claim names. The registry records the claim name and a reference to the specification that defines it. This section registers the claim name defined in Section 4.1. Values are registered on a specification required basis, which is in RFC 5226, after a 3-week review period on the Jot Reg Review at IETF.org mailing list, on the advice of one or more designated experts. However, to allow for the allocation of values prior to publication, the designated experts may approve registration once they are satisfied that such a specification will be published. Registration requests sent to the mailing list for review should use an appropriate subject, e.g., request to register claim. Example. Within the review period, the designated experts will either approve or deny the registration request, communicating this decision to the review list and IANA. Denial should include an explanation and, if applicable, suggestions as to how to make the request successful. Registration requests that are undetermined for a period longer than 21 days can be brought to the IESG's attention, using the IESG at IETF.org mailing list for resolution. Criteria that should be applied by the designated experts, including determining whether the proposed registration duplicates existing functionality, whether it is likely to be of general applicability or whether it is useful only for a single application, and whether the registration description is clear. IANA must only accept registry updates from the designated experts and should direct all requests for registration to the review mailing list. It is suggested that the multiple designated experts be appointed who are able to represent the perspectives of different applications using this specification in order to enable broadly informed review of registration decisions. In cases where a registration decision could be perceived as creating a conflict of interest for a particular expert, that expert should defer to the judgment of other experts. Section 10.1.1 Registration Template. Claim name. The name requested, e.g. ISS, because a core goal of this specification is for the resulting representations to be compact, it is recommended that the name be short, that is, not to exceed 8 characters without a compelling reason to do so. This name is case sensitive. Names may not match other registered names in a case-insensitive manner, unless the designated experts state that there is a compelling reason to allow an exception. The claim description, which for ISS would be issuer. The change controller for standards track RFCs lists the IESG. For others, give the name of the responsible party, other details such as the mailing address and stuff like that. Then the specification document, reference to the document or documents that specify the parameter, preferably including URIs that can be used to retrieve copies of the documents. An indication of the relevant sections may also be included, but is not required. Okay, section 10.1.2, the initial registry contents. So it has the claim name, it has the claim description, it has the change controller, it has the specification documents. Yeah, okay, and then it's got a bunch of these different ones for all of the claims that we reviewed earlier. Section 10.2.1, registry contents. This section registers the value token type JWT in the IANA OAuth URI registry established by an IETF URN subnamespace for OAuth, which can be used to indicate that the content is a Jot. Okay, section 10.3, media type registration. Section 10.3.1, registry contents. This section registers the application/Jot media type in RFC 2046 in the media types registry in the manner described in RFC 6838, which can be used to indicate that the content is a Jot. The type name is application. The subtype name is Jot. The required parameters are none. The optional parameters are not applicable. The encoding considerations are 8-bit. Jot values are encoded as a series of base 64 URL encoded values, some of which may be the empty string, separated by a period, by period characters. Security considerations, see the security considerations section of RFC 7519. Applications that use this media type are OpenID Connect, Mozilla Persona, Salesforce, Google, Android, Windows, Azure, Amazon Web Services, and numerous others. Fragment identifier considerations are not applicable. Additional information, is there a magic number? There's no magic number, no file extension, no Macintosh file type code. That tells you about the author. All right, section 10.4, header parameter names registration. This section registers specific claim names defined in that section before. Okay, I'm going to kind of skip over some of that. A lot of this information is almost feels like bookkeeping, but it's just about having a very, very strict like standards, rules that are always followed. Section 11, security considerations. All of the security issues that are pertinent to any cryptographic application must be addressed by Jot, JWS, JWE, JWK agents. Among these issues are protecting the user's asymmetric private and symmetric secret keys and employing countermeasures to various attacks. All the security considerations in the JWS specification also apply to Jot, as do the JWE security considerations when encryption is employed. In particular, sections 10.12, Json security considerations, and 10.13, Unicode comparison security considerations of JWS apply equally to Jot Claim Set in the same manner as they do to the JOSE header. Section 11.1, Trust Decisions. The content of a Jot cannot be relied upon in a trust decision unless its contents have been cryptographically secured and bound to the context necessary for the trust decision. In particular, the keys used to sign and or encrypt the Jot will typically need to verifiably be under the control of the party identified as the issuer of the Jot. Section 11.2, Signing and Encryption Order. While syntactically the signing and encryption operations for nested Jots may be applied in any order, if both signing and encryption are necessary, normally producers should sign the message and then encrypt the result, thus encrypting the signature. This prevents attacks in which the signature is stripped, leaving just an encrypted message, as well as providing privacy for the signer. Furthermore, signatures over encrypted text are not considered valid in many jurisdictions. Note that potential concerns about security issues related to the order of signing and encryption operations are already addressed by the underlying JWS and JWE specifications, in particular because JWE only supports the use of authenticated encryption algorithms. Cryptographic concerns about the potential need to sign after encryption that apply in many contexts do not apply to this specification. Section 12, Privacy Considerations. A Jot may contain privacy-sensitive information. When this is the case, measures must be taken to prevent disclosure of this information to unintended parties. One way to achieve this is to use an encrypted Jot and authenticate the recipient. Another way is to ensure that Jots containing unencrypted privacy-sensitive information are only transmitted using protocols utilizing encryption that support endpoint authentication, such as TLS. Omitting privacy-sensitive information from a Jot is the simplest way of minimizing privacy issues. And then we have section 13, which is references, which goes through a bunch of the different things that are referenced in this this document. Appendix A has Jot examples. This section contains examples of Jots. For other example Jots, see section 6.1 of this document and appendices A.1 to A.3. Okay. So then they show you the following example. JOSE header declares that the content encryption key is encrypted to the recipient using the RSAES PKCS1 V15 algorithm to produce the JWE encrypted key. Authenticated encryption is performed on the plaintext using the AES 128 CBC HMAC SHA 256 algorithm to produce the JWE ciphertext and the JWE authentication tag. Other than using the octets of the UTF-8 representation of the Jot Claim Set as the plaintext value, the computation of this Jot is identical to the computation of the JWE in Appendix A.2, including the keys used. The final result in this example, with line breaks for display purposes only, is this, and it shows the different parts of the Jot and how they're separated with periods. Then they have an example of a nested Jot. And they show the relationship between Jots and SAML assertions. Security Assertion Markup Language, SAML, provides a standard for creating security tokens with greater expressivity and more security options than supported by Jots. However, the cost of this flexibility and expressiveness is both size and complexity. SAML's use of XML and XML digital signature contributes to the size of SAML assertions. Its use of XML, and especially XML canonicalization, contributes to their complexity. Jots are intended to provide a simple security token format that is small enough to fit into HTTP headers and query arguments and URIs. It does this by supporting a much simpler token model than SAML and using the Json object encoding syntax. It also supports securing tokens using message authentication codes and digital signatures using a smaller and less flexible format than XML dsig. Therefore, while Jots can do some of the things that SAML assertions do, Jots are not intended as a full replacement for SAML assertions, but rather as a token format to be used when ease of implementation or compactness are considerations. SAML assertions are always statements made by an entity about a subject. Jots are often used in the same manner, with entities making the statements being represented by the ISS or issuer claim, and the subject being represented by the sub or subject claim. However, with these claims being optional, other uses of Jot format are also permitted. Relationship of JWTs to simple web tokens. Both Jots and SWTs at their core enable sets of claims to be communicated between applications. For SWTs, both the claim names and claim values are strings. For JWTs, while claim names are strings, claim values can be any JSON type. Both token types offer cryptographic protection of their content. SWTs with HMAC SHA-256 and JWTs with a choice of algorithms, including signature, MAC, and encryption algorithms. Then we have the acknowledgements and the mailing list. And there you have it. This has been a review of RFC 7519 on JSON web tokens. My name's Jacob Sanders. Thanks for listening to the end. And sorry about any mistakes I make while I'm saying or reading the content here. I haven't really practiced this probably as much as I should, and I'm basically doing this to learn just like you guys. I think what I'm going to do is probably have some follow-up videos where I focus on maybe an implementation of the like a Python implementation of this, or maybe I just talk about it myself, or show how I use something like a subset of what's explained in this document, like a simple JWT in some web application. I feel like I've used JWTs for some of my programs before, but after reading this document, there's a lot I don't know about what they really are. And so I'm interested in learning more about this, so I might have some more videos on this. Yeah, so for more information about this, I guess keep monitoring my channel. Maybe subscribe or something, I guess. Do whatever you want to keep up with the information. But also feel free to check out, I have a blog that I'm trying to develop and make like a good hub of high quality information, all related to programming. And that blog is at pieharbor.com. And so I'll be continuing to grow that blog as time goes on, as well as this channel. I kind of see this channel and that blog are like they're two sides of the same coin. They're all just about pretty much learning about programming and trying to, you know, help other people learn about programming. And that's it. So thanks. Yeah, check out my site and check out some of my other videos, and thanks for listening. You can give me feedback too in the comments. I haven't decided how I'm gonna actually relate to the comments, if I'm gonna read them a lot. I'll probably end up reading them, but I don't really know, since I don't know what to expect or what will happen. But feel free to post something there if you know you want to. Thanks.